So, hello, my name is Sebastian. I'm working for BELFOR as a technical director. In this tutorial, I would like to talk to you about the consequences of a fire in your infrastructure. Of course, you are insured, and of course you have got a strong insurance partner at your side. But nevertheless, a fire might have consequences which can be reduced, limited, and eased by a couple of very simple activities by you. And this would help you that, with the support of your insurance partner, that you can reduce the consequences, the problems, much easier, faster, and can go back to work. For this, I would like to have a look first on what's happening in a fire, what's happening after a fire, and this will very clearly go to the direction of corrosion. And finally, what can be done to avoid the consequences or to reduce the consequences. First, let us have a look on a fire. What's happening in a fire? What do you need for a fire? Well, you need flammable material. You need flammable material like this. Not only wood, it could also be plastic, for example, which is burning quite well. And you find this always in your infrastructure. Lots of plastic. You need oxygen. And you get, very easy, you get heat, light, you get water, and you get carbon dioxide. That's what you get when you have got, and that's all, when you have got a complete combustion process. Complete combustion process is very rare. So in most cases, you have got an incomplete combustion process. And well, in an incomplete combustion process, you get much more material. So what kind of material would you get? Well, in most cases, it's carbon. Soot. You know all this. You get soot, and but not only soot. It's called pyrolysis, and the pyrolysis is coming due to the lack of oxygen. And one of the material which you get, besides of soot, is a side product. And there are many, by the way. What kind of side products you have depends on what is in your infrastructure, what is in your hall. But the side product that you always will have is coming from PVC. PVC, polyvinyl chloride, is nearly in all infrastructure, in all modern infrastructure you will find it. It could be switches, it could be cables, it could be plugs, and a lot more. PVC is a standard plastic. Let's have a little bit a closer look. This PVC, well, contains carbon, which you see here. The symbol for the carbon is, let's take that here. Just a second. Carbon, hydrogen, and of course, chloride. Seen here in green. This is the most interesting one. Let's take as an example a cable of 50 centimeters, something like that, not more. And your infrastructure will definitely have significantly more PVC. So when you have 50 centimeter cable, a 50 centimeter cable, then you will also have 40 grams of PVC. And now let's burn this 40 grams of PVC. As a result, you will get more than 14 liters of a gas, hydrochloric gas. And this gas will sooner or later have a condensation process. In the condensation process, or due to the condensation process, you get 73 grams of hydrochloric acid. And hydrochloric acid has a pH of 0.3. Very, very low. Just to compare, this pH is much lower than what we have in our human stomach. Our human stomach has a pH from maybe something around 1. In this case, we talk about 0.3. So it's a very, very tough acid. What you get here. And the thing is, this acid is water dilutable. So when you have got water there, then it could spread the hydrochloric acid everywhere. So the question is, would you have water there? Of course you have. Lots of water. Well, then the side looks a little bit like that. So you have soot, of course, which is carbon. You have invisible hydrochloric acid all over. And you have a lot of metal, in nearly all cases. So, and now we must have a look what is happening with all this metal. What happens when you bring together acid and metal? Some kinds of metal are sensitive towards acid. And the sensitivity you might see here, this is just a nail. But on the nail you see something you all know, this is corrosion. Well, what is this corrosion? Let's have a little bit of a look to the corrosion, and we don't want to go too deep to the chemical details. Let's say we have got metal, and, well, if we add some accelerators, and by the way, the hydrochloric is a fantastic accelerator. If we add some accelerators, then as a result, we will get the corrosion process, which is, and that's important, is creating another substance. To make it simple, I call it simply something else. A couple of substances. Well, now we have a short view what this something and this something else might be and where they come from. And then we must have a look whether it could be critical or not. Imagine you have a lot of iron. And this should be a symbol of this iron. This is a symbol of all the iron atoms. Well, how does the corrosion happen? The additional material, the accelerator is coming. In our case, it's the hydrochloric. The hydrochloric is coming, and the hydrochloric is kicking 1 or 2 or 3 atoms out of the substance. Which means that iron atom is gone, but on the other side, the hydrochloric is gone as well. So, both are gone. Now you could say, okay, come on. Yeah, I have so many atoms, so if I lose one, don't care. Yeah, so, and yes, I might have 73 grams of hydrochloric acid, or maybe a kilo, or maybe 2, or maybe 5. But I've, on the other side, tons of iron. Tons. So, come on. Yeah, so what? Well, the stupid thing is this something else. So, if we look at this side effect of the something else, this something else might take or will take a connection with water. And there is enough water. There's always enough water. Because you had a fire. There are firefighters. They put tons of water. So you have enough water. So, and now a stupid thing is happening. The something else, the result of the first corrosion, is going into a liaison with water. And as a consequence, we get this something. This accelerator. Oh, stupid, because, well, the something plus the metal is leading to corrosion. The corrosion is leading to the something else, which, well, the something else with the water is leading to the something. And you see what I want to point out. What I would like to point to is, well, you get a vicious circle. It's a permanent process. It's a permanent circle as soon as you have got water and you have got a little bit of this hydrochloric, You don't need much because the hydrochloric is produced by the process itself. It's a permanent process. It will never stop. And that's one of the learnings which I would ask you to take in consideration. Once you have got the corrosion of the fire starting, it will never stop. If you don't do nothing, it will not stop. It will continue permanently. There's no hope. And the longer you wait, the more it continues. Corrosion will not stop from alone. Well, the question also is, the second question is not only that it is how long will it continue for eternity, but also how long will it take to start? And for this we have done a little video in our laboratory. And in this video you might see, well, sorry, that was the wrong one, no problem at all. So, in this video you might see that we have a metal plate, and below the metal plate we have some plastic. This is PVC, very cheap PVC as you can buy everywhere. Well, we have a watch, a clock, and then we start here. As you can see, we burn the PVC. And the burning process is not dramatic. It's not a big fire, it's only a few grams. And, well, we burn it so that is, you see the carbon, you see the smoke a little bit, and the smoke is somehow a little bit touching the metal plate. Not very intensive, there are no big clouds. It's not a dramatic fire. Yeah? And you see our experiment will stop within a few seconds, nothing very long. You see some traces of soot, but, well, what you see here, that's more or less is it. It's not a big fire, it's not a massive fire. So, that's it. And now, the only thing we have to do, very easy, very simple, we have to wait. And in this next video, we'll see a little bit what's happening. So, you see, we'll wait 1 hour, 2 hours, 3 hours, and after 3 hours, you can already see, oh, something is changing. The color of this plate is a little bit changing. It's getting a little bit reddish, and we all know what it is. That's corrosion. So after 10, 11, 12 hours, the corrosion is already visible. It's clearly visible. And we have done our little experiment for 19 hours, not longer. And please be sure, there is no way to get help within 19 hours or before 19 hours. 19 hours is nothing. Even when you call your insurance, when they are very quick, when they have an adjuster, when you have helpers coming soon, 19 hours is nothing. So, what can now be done? The corrosion is a process which is infinite. The corrosion starts very quickly. What to do? What can you do? There is something you can do. So when you look to that, well, you have a couple of challenges, mainly 2 challenges. The first one is the corrosion does not end, it's infinite. If you do nothing, it will get worse. And the second step, the corrosion process starts soon. It starts after an hour, after 2, after 3 hours. It gets visible soon and it will not end. What we recommend is think about of a couple of activities. So the first recommendation you could get is act fast. Yes, you have an insurance. Yes, they will help you, but it might take time. You would have an interest in reacting fast. Act fast. Now you say, well, okay, yes, we act fast, but what should we do? Well, in this case, very simple. The first activity, the first impact dry down, reduce humidity. There will be, and you don't get to zero. No way, you can never go to zero. But you can reduce it. And the more you reduce the humidity, the more you win time. Because the less humidity, the slower the process. Slow down the process and win time. This drying process is something that companies like BELFOR can do. And the drying process is something that is not dramatic. It's not so complicated. It can start soon. It can start quickly. It does not solve the problem, but it helps you to win time. It slows the process. And then, because, and just to understand, if you dry, you reduce the water. And without the water, the process of creating the accelerator again is slowed down. You have less and less of this accelerator material, of the hydrochloric, and that means the whole vicious circle is going slower and slower and slower. The second, what you could do, try to remove the corrosion accelerators. They are there, and there are a lot of technologies which can reduce them. Maybe you don't get to zero, but the combination of reducing water, having a low humidity, and the processes to clean and reducing and then measuring this material, this accelerator, this hydrochloric, which can be done, means that the vicious circle is somehow stopped. Maybe there might be remainings, but okay, that's not relevant. But so you can, realistically spoken, stop the process. So think about, in your own interest, even if you have a strong insurance at your side, act fast, reduce humidity. The drier it is, the slower the process, and you win time. If you have time, you talk to your partners, you talk with a restoration company, maybe you talk with a big restoration company which has the capacity to quickly bring material, machines, staff, experts on site. Then the next step would be remove the corrosion accelerators and stop the process. This could help you to reduce the damage and to go back to work, to go back to production quickly. That would be our recommendation. We wish you good luck and think about this in order to be protected and to be prepared. Thank you very much.